Now for our fourth and final atmospheric lifting mechanism, warm and cold fronts. Before we begin, let's identify where on Earth we have warm air meeting cold air. It won't be there along the equator where we have warm air meeting warm air. Instead, it's going to be in the mid-latitudes, which we find Indiana and much of the United States, which I now showcase from the top view, where the previous was from the side view, the cross-section view of our atmosphere. Much of the eastern United States, including Indiana, is influenced by a maritime tropical air mass from the south, from the Gulf, and from the Atlantic, but also a continental polar air mass from the north, from continental Canada. So very much this is an area that's a battleground between being dominated by warm moist air or warm air, but also cool, colder air. And so let's look at an instance where we have warm moist air, but then cold air is coming and penetrating an area that is overwhelmingly warm air. The leading edge of that penetrating cold air mass is called a cold front. And so when we think about a cold front, one thing that we'll need to note is the fact that it's faster, oftentimes moves faster than a warm front. Not too important now, but it'll come back in a future video lecture. Key to a cold air mass is it's going to be colder. Obviously, it's heavier, it's denser, and so because of that, it forcibly lifts up. It wedges underneath a warm air mass when it's penetrating it. Another characteristic of a cold front is often along it you have quick, short, heavy downpours. And so if you think about those days in which you can see these clouds coming, off in the distance, these clouds arrive, heavy rain, quick dose of thunder and lightning and rain, all hell breaking loose, and then eventually it moves along, and then about an hour later it's clear, it's nice and calm. That's probably a good example of a cold front moving through the area. Characteristic of a cold front is those cumulonimbus clouds that we've talked about in a previous video lecture. Tornadoes, thunderstorms, oftentimes are severe weather. We associate them with cold fronts more than warm fronts. Although they do occur occasionally with warm fronts, more oftentimes, we're going to associate them with cold fronts than warm fronts. When we see on a weather map, when we see this symbol here, that is an example of a cold front. The direction that the triangles are pointing is the direction that cold air mass is moving. So in this example here, a cold air mass is moving from the bottom of this slide to the top. And on our right side of this image here from National Geographic, we can see the cold front. So to the left is a warm air mass, and to the right we can see rain coming. And so what's happening here is cold front. The cold front is arriving, and it's essentially wedging underneath the warm air and quickly forcing it upward. Oftentimes when people take pictures of clouds and they're like, wow, look at this weird cloud, it's a cumulonimbus cloud. And so once again, we often associate those with either convection, like I talked about beforehand, or the arrival of a cold front. And all the death and destruction from tornadoes and hail and all that, we'll talk about in a future video lecture on severe weather, but those, like I said before, typically are associated with a cold front. Here's a cold front over Santa Ana, California, and so the towering cumulus cloud that became a cumulonimbus cloud signaled a rapid uplift of warm, humid air over an advancing cold wedge. And as you know, I like to try to make things as simple as possible, and so of course this red is signaling an area that is a warm air mass. But we have approaching a cold air mass, so a cold air mass is coming into contact with the warm air mass. What ends up happening is the warm air is forced up. And you can see that at the bottom, you can see how it wedges underneath the warm air mass, in which that cold air mass quickly lifts up the warm air, which then continues to go vertically, causing that cumulus cloud to become more of a cumulonimbus cloud, a vertical growing cloud. One characteristic to note with a rather intense cold front that really wedges underneath a warm air mass is what they call a downdraft. And oftentimes before a cold front arrives, you can feel a little bit of a chill in the air, you can feel a little bit of a breeze right before it rains, and oftentimes you can maybe even smell the rain coming. And that's because of this downdraft. And so while you have the warm air being forced up, at the same time you have a downdraft that's occurring. We're going to come back and relate this to the Indiana State Fair tragedy a little bit later on. Of course, as that warm air starts to rise, eventually it's going to condense, cool, and fall back down as rain. And so we get those quick, heavy downbursts associated with a cold front. More characteristics of a rather intense cold front is a very much a vertically growing cumulonimbus cloud, what we can see here. One characteristic of a cumulonimbus cloud is it has an anvil shape in which the top actually is almost arrives ahead of the cold front. What happens there is the upper level winds are moving a little faster than they are at the bottom because there's friction with the surface that slows it down, or at the top there's less friction. So what happens is the top of these clouds kind of have this typical characteristic shape in which the top pokes out like that. One of the things we're also going to see once again with cold fronts is heavy rain, and oftentimes hail, which is a dead giveaway that the cold front has arrived, and so the hail typically arrives before the heavy rain. The inverse of a cold front would be a warm front, which is the leading edge of a penetrating warm air mass that's penetrating a cold air mass. As we know, warm air is lighter, it's less dense than cold air, and so what happens is when the warm air penetrates the cold air, it's gently lifted up over the cooler air mass. As it gets lifted up to a certain point, it once again cools and condenses, which is key to understanding precipitation characteristics of a warm front. Characteristic cloud formation is that you would find those all-day long periods of drizzle, those nimbostratus clouds. Those stratus clouds are very much dead giveaways that a warm front is arriving. So if you like warmer air, sometimes you have to put up with a good steady dose of drizzly all-day rain, in which it's not a really heavy downpour like we saw with the cold front, but that light drizzly rain, very characteristic of a warm front that's soon arriving. On a weather map, when we see this symbol, this is a symbol that showcases a warm front. So in this characteristic, the semicircles point the direction that the warm air mass is moving. And so in this example here, the warm air mass is moving from the bottom of the slide to the top. The days in which you see a cloud type like this, a stratus cloud, means a warm front might be arriving or soon arriving. And the same goes for this photo. As a warm front arrives, that warm air is gently lifted up over the backside of a cold air mass. And so oftentimes the first signal that a warm front is arriving is cirrus clouds that we can see here on the top left of this image. As that warm front gets closer, you are likely to see more stratus type of clouds. And possibly those nimbostratus clouds could soon arrive. And so we can see here, instead of wedging underneath the cold air mass, the warm air gently rides up the backside. And now we're getting more drizzly rain here at the surface. However, the warm front hasn't actually fully arrived at the surface yet, but it's getting closer. So we have those all-day periods of rain. We know, though, once that rain clears out, we're going to get warmer temperatures. And finally, now this area is dominated by warm air. Using radar technology, in which a plane flies essentially through a warm front and through a cold front, what they did was then they can then see the side view, or the side perspective of each of these based on precipitation and characteristics picked up via the radar. So on the top you can see the warm front. So the blue is illustrating precipitation. And so you can clearly see what I just showcased beforehand on the right hand side of that top image, that gently riding up the backside warm front. Whereas at the bottom you can see the cold front, how it wedges underneath the warm air mass, but you can also see those upper level winds which cause the actual cirrus clouds, or those upper level clouds, to precede the arrival of the cold front. Here in Indianapolis, it's a very cold, dry day as a cold air mass dominates the area. However, warm air is moving into the area, and so as it moves into the area, we can see changing weather conditions, changing cloud types, changing levels as far as where the clouds are. Precipitation characteristics change. The barometric pressure might lower as that warm front arrives. And then brings Indianapolis some warmer air. And so here we got warm air, but that warm air is getting ready to be penetrated by a cold air mass, and so we can see how that cold air has wedged up and forced up that warm air. And so we can see characteristics of a cumulonimbus cloud, in which we have that anvil top shape, in which those upper level winds are blowing faster, actually causing the clouds to precede the arrival of the front. What's going to happen now is precipitation characteristics change. Indianapolis will see a barometric pressure increasing as that cold front comes through this area, and then providing us the situation we had at the beginning of being dominated by a cold, dry air mass and that high pressure.